making HTTP requests. As simple as that. Most likely you know tools like Postman, VSCode REST client or other things. And when it comes to complex tasks, they reach the limit. And what we miss is programmability. And what is that about? I will show you today. Plus, by learning this hands-on HTTP daily workhorse right along the way, you will gain some insights into a new language that is expressive, extremely powerful, and with some features that are really unique and fresh. In order to have something we can play with, I've developed a small node server that's all about cities. So let's get started. All you need is VSCode, the Ionide extension, and the latest .NET SDK installed, and you can just start with a script as you see it here on my screen. We can run our service by just typing node app.js, and here we go, it's running on ports 5000 and 6000. The first thing we have to do is reference the FsHttp package and open up some namespaces. Select the content and send it to the interactive environment by pressing Alt-Enter. Making an HTTP request is really straightforward, and it looks like you would do it in .http files or similar environments. What you see here is a request definition. In order to send it, prefix it with a percentage sign and send it to interactive. And as a result of our service, we see here the response and its content encoded in JSON, and we see all the cities, their current condition, and some other useful information. You can easily extend the request by query parameters or other header values if you think that is necessary. But what about programmability that I mentioned before? So we could easily get some weather information of historical data. So I can evaluate the request, and as you can see, we get many samples, one sample for every day, with the min and max temperature and the mean. And what we would like to have now is the following task. I would like to know what was the day that has the biggest temperature difference in all the data we get. To be able to answer that question, it is very helpful to bring the data that is returned from the service into a structured form. Now, there are many ways to do that, and I'll show you the one that I find most practical. So what we do is we pipe our response into the deserialized JSON function, and to that function on type level we pass a type definition, because we say we expect the returned data to be a list of this anonymous record. And there are also alternatives, but I like to see very explicitly with what we have to deal. And we do not have to be complete in that example. It is enough if we just have a sort of overlay for the data we are actually interested in. And when I evaluate that expression now, you see that we basically get the same data, but in another structure. It's not just text as JSON, but is really like compiled code and deserialized values. And by the way, this is really fast because this is compiled and partially optimized code. So what was the problem? We wanted to have the year that has the day with the biggest temperature difference. The temperature difference is the difference between min and max, and we have to group all that by year. So what can we do? Our resulting list we group by year. Now imagine that it's very expensive to do our HTTP request and it would return always the same data. So what can we do? We can just bind the result of the request and the deserialized data to an identifier and use that in our subsequent expressions like so. So now I can evaluate that expression and just use that identifier to reference the value bound to that expression everywhere where we want. So for example, I just take it and use it here in our pipeline, and we get the same result as before, which we expected. Also, it is really easy to make just a function or more functions out of it, because we are just here on an expression level. And I can say I want to have the get historical weather function that gets a city as parameter, and I have the get year with biggest temp difference that then actually gets the year with the biggest temp difference. And I can extract a named type out of the anonymous type that we have, and the type inference magically understands what we want to do. You can see that by having a look at the pipeline hints, and the compiler just magically infers what we are working on. And I can say, we have that composability thing. So we have these two functions now, and we can easily compose a pipeline and evaluate it. And you see that, again, we get the result that we expected. Sending data is almost as straightforward as getting it. So imagine we can get some current weather conditions of a city, like so. We get the temperature in Celsius and the humidity, and now it is possible just to update these current conditions by using a put. For output, we require a JSON encoded body. And now there are several ways to achieve that. So the first is very easy. You just specify a JSON in form of a text. Now, since this is a string and we might want to use some interpolated values, I recommend to use $, triple quoted string, which is the most easy way of writing JSON with interpolated values. Now I can take that expression and evaluate it. And as you can see, the service returns us the updated value of the 8 degrees Celsius and 50% humidity. This is of course also possible if you just specify a record and send it to the server. Now imagine if we would like to read the current conditions of a city, change its temperature and update it by sending a put to the server. I show you just how easy that is. So the first thing we need to do is we extract a type of our anonymous record. Then we make a function to get the current conditions of a city. Then we make a function that takes that record, updates its value, the temperature value, and send it back to the server. So once we are done, we can evaluate our functions and types, and we can update the temperature of Frankfurt. But there are other scenarios where programmability and a high amount of flexibility is required and involved. Just imagine authorization, authentication, and things like that. So for this example, we want to delete a city. And if I try to do that, you see that we are not authorized to do it. So in our case, we have set up a pipeline that uses JOT tokens, and the tokens itself, they are encoded with a security key and they are validated by an issuer. So this is the authentication part. So only the tokens that are authentic, means that come somehow from us, are validated as valid and authentic token. And then the delete endpoint for our cities, it requires a role. So once we understood that someone is sending us a token that is authentic, means that we have issued, then we require a role. And roles, this is a form of claims that are encoded in the token. So do not mix authentication and authorization, but using this way of JOT tokens, we are able to fulfill both. So what can we usually do? In our testing scenario, we would like to create a authentic token on the fly. For that case, I've just assembled some helper function that uses the identity model tokens infrastructure of Microsoft, provided by this package. It's not so super important what exactly happens here. The only thing is that with a security key, and we have an issuer, a username, and a sequence of rights, in our case the role claims, we would like to have a token encoded that we can then send to the server. The server validates it and checks if the required roles, if any, match the roles that we say we have. So in order to use that functionality, we just have to load the script that we have just seen. And also in addition, I have a vault that enables us to get some secret information for certain environments. The vault basically looks like this. There's a type defined for environment settings, a security key, and an issuer. And as you can see, this is just hard-coded, but in a, let me say, real-world development environment, there would be some real implementation behind this. But for our case, this is enough. But please do not do that in production. Do not hard-code these values. They should be stored in environment variables or in some other type of vaults if you're in production in some secure store and management environment. So creating a token is very easy. We just use the encode function that we have just seen, we pass a security key and issuer, a username, and a list of roles. So we can then, on every request, create a token on the fly and pass it as a bearer token to the server. Once again, we evaluate that up front. And now when we make a request, everything works expected. And then to check if our city really is deleted, we can just try to get the city and we see that it's not present anymore. Now imagine that almost all of our endpoints require authentication and authorization. So we would just like to pass a bearer token per default for every request that we are sending. To do that, we can just pre-configure that HTTP builder, as it is called, in a way that the token is always included. So as you can see, we bind such a predefined request to the HTTP auth identifier, and also notice that we do not send that request. So we just leave it as it is because we don't want to send it. It is just, let me say, a sort of configuration. And we can use that configuration just as we would use HTTP, only that we say we would like to have the HTTP with authorization pre-configured. And I have to evaluate that expression one time, and then I can use it as many times as I want when it is in our context. Also, please note that this is evaluated and also the token is generated at the time we evaluate that expression. If you would like to have a lazy evaluation, we can just make a function out of that. We can make a function call here, and then we get a, let me say, fresh token every time we evaluate the actual request. We've already learned a lot. We know how easy it is to make HTTP requests. We know how easy it is to work with data, how easy to work on the level of types, how we can turn expressions into functions, and much more. And now we can take all that knowledge to go even one step further. So for our new use case, we would like to target different environments, because this is something that I've encountered to be very useful, and we just have to do it. So usually we have a development environment, we have our local environment, a staging environment, a testing environment, a production environment, and whatever environments you can imagine. And these environments, they have a lot in common, they share a lot, but they also differ in certain cases. So in our scenario, what I have done is I have just one service, and the service is listening on 2 ports. But this should be like, okay, we want just to target 2 different environments. They share the same secrets and so on, but this is not so important. In reality, there would just be 2 different environments. We just expose one and the same thing on 2 ports. So our goal is to formulate and make HTTP requests for every environment we have, just in a way that we do it as we have seen now, with the only difference that we say, hey, I just want to specify which environment I want to target. And how can we do that? So the first thing is we have to identify the differences of all our environments. And I mean, the first difference that comes in mind is the base address. So the first environment has port 5000 and the other one has port 6000. So that's one difference, the base address. And in our case, the other difference is that the tokens, they do not share the same security key and issuer, but they have different security keys and issuers. So these are the 2 differences that I've incorporated in our demo scenario. Of course, in other scenarios can be much more, but I think they are enough to demonstrate how we can achieve that and how easy it is. So the first thing is we should always keep in mind that the things we do, that the code we write is and remains composable. And composability means we have smaller blocks and we can just compose them to bigger blocks, and we can take that big block and compose it with other whatever kind of blocks to bigger blocks, and so on and so on. It's that Lego principle, you know, it's not Playmobil principle, where you can compose just nothing, where everything is just a big thing but it's not composable. But Lego stuff is, or at least when I was a child, was very composable. And always keep that analogy in mind, because this is very helpful. And usually objects are not composable, but that's another story, but I will tell it to you. Not today. So the first thing we want to do is we want to make our make token function independent of an environment. And which environment information we have here? We have security key and issuer. They are environment dependent and we would like to factor them out. So what can we do? Yeah, very easy. We just say security key and issuer you have to pass from outside. So that's the first thing. And since security and issuer somehow all belong together, I just make a type out of it. So to have that pack is a little bit more readable and easy. And now, as we can see, this is required here where we pre-configure our HTTP builder. We just need that authorization and authentication info in order to generate the token, which means we have to pass in our pre-configured builder author and auth info, so an environmental information. So to make our life easier, we just wrap all the information we have into some environments to have an easy access for it. So what I can do then is I just restart our server, pass the environment I would like to target to our HTTP function. Of course, I have to evaluate everything up front one time. And then I can try to remove whatever city, because Paris is just too beautiful. I also like Frankfurt. I start with Frankfurt, but it's just removed from the data. Don't worry. And as you can see, it was working. So now the second thing that we said is different is the base URL. And this is an edge case because that pattern that I've just introduced, we can do basically with every header that we want. We can configure every header in that kind, but the base URL and also the verb is something a little bit different because this is a merge between the HTTP verb and the actual URL. And how that can work, I just show you, and this pattern you can just repeat if you really require that. So the first thing is what we would like. We do not want to name that HTTP auth because this is much more now. It is an HTTP for our environment. I just call it HTTP env. And in addition to the auth infos, we would like to pass a base URL that we use for every request. Now the pattern is this. When a request is actually sent, we transform it in the way that we take the address that is passed by the user, which would be that part, and we add it to the base URL that we pass here in the HTTP environment. To make things a little bit more easy for us when we actually execute these things, I just merge base URL and auth info into one type, which we then use instead of these two. Also, please note that the compiler and our tooling is able to infer that env info must be of type env info just by the way that we are using it and by the types that are here in context. This is really great. We have also then to extend the infos here in our envs that we actually know. So because this is not just an auth info, we'd like to have an env info, and we can easily change that. So as you can see, we have captured all the differences of our environments, testing and local, in the way that we have the base URL and the auth infos just as we wanted to have. And now this is very easy to use. So all we need is we have our pre-configured HTTP builder for an environment, and we just pass the environment that we would like to target. I can of course remove the base URL. Before I can use it, we have to evaluate the stuff that we have written up front. We have to evaluate it one time. So in order to use it, and we want to remove London from the list of our cities, I can just evaluate this, and it was working. So the request was actually sent to port 5000 using the token. I can say now I want to target a different environment and I would like to remove Paris. And this is also working, sending to the correct base URL using, of course, now another token. But if you don't believe me, just try it and play on your own. And there's also some alternatives just as a side note. So if you are not coming from functional languages, but you are used to languages like TypeScript, JavaScript, Python or C# or Java, you might be more familiar with so-called fluent syntax or dot notation. And this is also possible. I would just like to show you how. So you open these two namespaces, and then basically you use dot notation. So you say http.get and pass the address. You say .send There are, of course, if you are in a production environment, there are also async overloads for this, which you should use. Do not block your threads because we do not have green threads in .NET. You can deserialize. This is basically all the functions you see, you have seen before, are present here. You can group by, you can select, which is map for people who are not familiar with C# speak. Map is called select in C#, and we're using some C# idiomatic things here. And this is working. This is working as well. So I can evaluate that. I can get the data, and I can get the result, and this is the same result as before. Here you have the opportunity to just try on your own and see how it works out for you in a real world practical cases. Thank you very much for watching. I hope you enjoyed it, and stay tuned for some more content.